going to be looking at how you can find the C++ equivalent functions to nodes you might be using in Blueprint. In the last lecture, I magically went and did that. I went and found that get component location was the replacement for get world location. And also I used this function, this mysterious function called get forward vector. Now, how did I know that? How did I know that I needed to include the ukismet math library at the top as well? How did I know all of this? Well, actually, the process can be fairly straightforward to map the two, and the trick is in hovering over the nodes in your Blueprint graph. So if you've got, for example, get world location, as I've got here, I'm in the BP grabber, and I am in the private function called get hold location, which is what we're going to be migrating across in this module. And if I hover over get world location, you can see that the target is scene component, which makes sense. In fact, it is a uscene component in C++. And if we hover over the get component location, we should be able to see that indeed that is on the uscene component, and it is on the uscene component because we are applying it to this grabber. If you go and have a look at the node, you can see that the target is actually self, this current blueprint. So that's kind of how this is starting to map across. But then you see that the name is different, and you think, well, how did I find out that the name was what it was? Well, there's two ways of figuring this out, really. Well, the best way to figure this out is to actually go and have a look for where that name is coming from in the source code. So first things first, we need to go to the file that declares the uscene component, the uscene component header file. Two ways of doing that. You could select any of the symbols to the uscene component and hit F12, or you could do a control comma to bring up Visual Studio's go to all, and you could just type in scene component, all one word without any prefixes, and you can see that there's a lot of stuff comes up here. If I add .h, then we can go straight to the header file. Let me just close down this view, and we can see the tab that has opened up is the scene component.h. Now, in this file, if I looked for get world location, you can see that it is actually some of the metadata applied to a u function that is obviously callable from our blueprints. And you can see that the actual name in C++ is k2 underscore get component location. That doesn't seem very nice. That doesn't seem like what we should be calling. So if you hit F12 to go and have a look at its definition, you can see that all this is doing is calling to another function called get component location, and that's what we ended up using. So oftentimes there are wrappers for the blueprint around C++ functionality, and in C++ we can just use the C++ functionality directly. And we'll see the same sort of wrapper stuff going on when we talked about that forward vector. So we've got, again, a node which is get forward vector. How did I know that I need to use the Kismet math library? Because if you hover over the node, it says that the target of this is the Kismet math library. Now, it doesn't have a self because it's actually a static function. So if I, again, do my control comma trick and I go to Kismet math library, .h, and we go and open that up, you could go and search for what was the function get forward vector, and there's basically here, there's get forward vector. It's a static function, but if I F12 into it, you can actually see that I could simplify the code that I've got in my grabber.cpp. If we go over to the grabber.cpp, you see I'm calling this big static function to get the forward vector. But what this is telling me in the Kismet math library is that the implementation is just calling .vector on our rotator. So that's what I could replace it with. Instead of getting the forward vector, I can just do my get component rotation .vector, and that gets me the forward vector of a rotator. Now, you could repeat this approach with all sorts of nodes. For example, in our function in the grabber BP, if we look for trace for physics bodies, you can see there is a sphere trace for objects. If I hover over that, then it is going to tell me where this came from. And indeed, in this case, it's saying it's coming from the Kismet system library. So again, you could go and have a look at that. You could see that there is a bunch of cool stuff that the Kismet system library is doing, so you probably would want to use that, but you could also use some of the underlying stuff that the Kismet system library is using. And by the way, when we see the word Kismet, this is often code for Blueprint, because Kismet is the system that predated Blueprint and came before it, and Blueprint is its successor. But throughout C++, we often have reference to Kismet or K2, and that is basically what it's saying, that this stuff is libraries specifically intended for use with Blueprint. So let's have a look at some of the most common includes you are going to encounter. The first one is UWorld. UWorld is the class that represents a map or a level. And that's a bit confusing because in Blueprint terminology, that world is very little used, but you do see this terminology crop up in the world outliner. So that's how you might be able to remember what it means. And its include is engine/world.h. Then the actor. So a actor is under game framework /actor. The U component, and in fact the scene component, is located under the components folder. The U gameplay statics, which we haven't encountered yet, but does crop up quite a lot, especially for things like getting a player controller. So if we had the get player controller here, then if you hover over that, you can see that that goes to the gameplay statics. And gameplay statics is often just a wrapper around some other stuff like UWorld, but it's often a very helpful wrapper, just like the Kismet system library, which is on the next line. And then whenever we see things like the Kismet math library, we can usually just imagine that that's a wrapper around something in FMath or something on the particular classes. So if it's a F vector, then you might have functions on the F vector or the F rotator. And if it's utilities like clamping and lerping and sine waves, often they have counterparts in FMath. So I recommend using the counterparts from FMath. You can use the ones from the Kismet math library if you want to, but FMath is essentially the underlying thing in C++ anyway. So let's put some of this into practice by bringing across some new functions. The two functions that I want to bring across in this module is the getHoldLocation and getPhysics component, bring them over into C++. In order to do that, getHoldLocation does reference a variable that is Blueprint only, so we need to bring that variable across too, which is the hold distance, but we know how to do that already. In fact, if you're feeling very confident and want to give this a try, you could pause the video and have a go, then come back and see me do the result. So first off, we'll go into the grabber.h and close down any extraneous tabs that we don't actually need. And we're going to create a new U property, and it's not going to be the max grab distance, but it is going to be the hold distance. So let's call it that. And I'm just going to fix up the indentation, which often gets messed up by these macros, unfortunately, in Visual Studio. Now, what do we want that hold distance to be? Well, 100 seems to be the default there in the Blueprint anyway, so that's what I'm going to stick with. And then hopefully we should be able to go ahead and build the result. And as a result, we see that our hold distance now has this _0, and I'm not going to bother replacing it just yet because we're just trying to get this getHoldLocation function over into C++ anyway, so let's do that first. Let's copy, or let's just type it out for simplicity's sake. We're going to do an F function. We want it also to be Blueprint callable, and we do want it to be Blueprint pure as well. And it's going to return what? Again, it's going to return an F vector. It's going to be called getHoldLocation, and it doesn't need to take any arguments. It is also const. Now, I am going to go ahead and copy the signature to the clipboard, and we can have a go at the implementation. Now, the implementation should look very similar to our get max grab location, because pretty much we're doing the same sort of thing. We're just adding the hold distance instead. So let's go ahead and actually copy most of this and just multiply by the hold distance. Now, if you were doing this a lot and you had a lot of repetition like that, then I would suggest trying to create some sort of function. But at this stage, I think it makes sense just to have a bit of duplication. So after we have compiled, we should go in and see that our hold location is now giving us an error, and we can delete the hold location, delete the hold distance. Now, hopefully in the event graph where our getHoldLocation is being used, it has been updated now to the new version from C++. So what also remains for us to take across is this getPhysics component. Let's see where getPhysics component is used apart from here in the event graph. Find references. It's used in a couple of places. It's used in grab, it's used in release, and in the event graph itself, of course, and in the creation of the function. So we want to do this equivalent over in C++. So that requires us to know what to do with converting these two nodes. So the first one is getOwner, and you can see the target is the act component, but actually the target is ourselves because act component is a superclass of the scene component. So we should be able to see quite easily how to get hold of that. Then we have get component by class, which the target is actor. And I'm going to show you how we can find out what this implementation is in C++, but also how you can use a slightly easier thing in C++ to get hold of the physics handle. But first we have to do the signature. So let's go over to the grabber.h and we're looking for our getPhysics component. That's what we're going to create. And it's going to be pure as well and blueprint callable. So exactly the same as before. So I'm going to copy the U function, and our return value here is going to be of type physics handle component object reference. Okay, so let's have a look. We know that the type is a physics handle component. What is that type? If you want to try and find it, we could do a control comma again and do a physics handle component. And you can see we've got physics handle component.h. And if we open that up and hover over the tab, you can see that the path is quite long. I just want to show you how you can cut down a path that is this long down to one that makes more sense. Usually you start after something like classes or public. You don't have to include the whole thing. And usually there's only one folder. So it is physics engine / physics handle component, I think, that we want to include. So let's go over to our header file. And just above, again, remember the last include in this file has to be the generator.h. So just above that one, we're going to do a # include physics engine / physics handle component, like so. And that, if we open it up, where is the actual class here? It's called U physics handle component, which we should have kind of anticipated because we know that U is the prefix for a lot of things. And because we're dealing with a reference, this needs to be a pointer to a U physics handle component that we're returning here from our blueprint callable. And then we're going to call it get physics component. It doesn't take any arguments, and it should also be const because we're not actually modifying anything in this getter. So let's copy the signature, go over to our C++, and try and create an implementation. So getOwner is fairly straightforward. You can just call getOwner on the grabber. So getOwner will return us an actor. And then we need to dereference that actor in order to call something on it as the target, which is going to be our get component by class. Get component, let's see what's available there. Nothing's showing up. The reason this isn't showing up is because we haven't included our actor header. So there is a two fairly straightforward ways to do this. The first one is we could try and click on the actor symbol somewhere. So we could jump to the getOwner definition, and then we could jump to the return type with F12, and that would take us to the actor file one way. The other way is to use the control comma again to do the same thing. And as we've said, it's game framework / actor. We said that in the slides already. So this one I can just include in the C++ file. It's going to be # include game framework / actor.h. And that means that now we can dereference getOwner and our IntelliSense should work. So get component by class, you can see that that is an option indeed, but I'm saying that there's a better option. If we F12 to the definition of that, I'm actually going to go to the header file by Control KO and try and look for the same get component by class. And what we will see here is that there are a lot of functions with very similar names. Find component by class, get component by class, get component by tab. And further down here, just a little bit, there's a templated version, find component by class. And you can see the template automatically does some casting for us. It's just a little bit nicer to deal with because we know that we're going to get the right type back. So let's do that one instead. Find component by class. And we know that the type we want is the U physics handle component, and that's all we have to do. We don't have to pass anything into this function. The templating does everything for us in C++, and that's what we can go ahead and return from our function. And because the function types match up, you see the return type there is a pointer to a U physics handle component. So once we've gone ahead and built that, and go over into our blueprint, you can see we've got our error, but we can now delete get physics handle component, compile, and all the references to get physics component have been updated and are now calling to our C++ code. So if we go ahead and test it out, everything should be as before. Hopefully you now understand what some of the common includes you will see in C++ are and do, also how you can find these includes from existing Blueprint nodes or use Blueprint to discover functionality and hopefully feel more confident into diving into the C++ in order to find the underlying functions that are being wrapped and the correct include locations.